Hi guys, hope all of us are doing great. My name is Ernest and this is Ernest Sciences and the Mathematics TV channel. Before we proceed, I'd like to kindly request our members to go to YouTube and search Ernest Sciences and the Mathematics TV channel. Subscribe and engage us in the comment section and also check our, of course, uploads in various social media platforms. I'm going to put a link in the description boxes for various other videos that we've done on similar topics. So in today's discussion, we're going to look at the concept of trigonometric functions, and this is going to be basically biased on, of course, the elementary real functions that are discussed on the concept of calculus, and this is going to entail some of the ideas that we have learned in one way or another under the concept of trigonometry. And of course, I had mentioned that we are going to, of course, these specific trigonometric functions in terms of the three basic functions of the sine, cosine, and tangent. And there are various reciprocals for the cosecant, secant, and tangent in that specific order. So in this particular case, then therefore, we're going to look at these specific functions in individual sets, whereby we had said that for these three specific set of function, for the sine, the cosine, and the tangent of these particular representations, they're going to have their inverses, as I have mentioned, of the cosecant. And then we have the second, the cotangent of various functions given in this specific format. And therefore, we are going to look at each individual set of these basic functions and how we can be able to represent them, and how we may, of course, be describing them in various aspects of calculus that are mentioned earlier in this specific discussion. So we're going to start with a function of a sine. The sine is going to be representing a set of real numbers that can be described or defined as the sine of x. And this sine of x is going to present an angle measure of x in terms of radians, whereby this specific, we have said that we are going to consider radians given in that specific format, whereby this particular set of R is going to consist of x for all the set of numbers which are going to be formed by a set of real numbers given as such. And for the concept of the sine and the cosine of theta, we're going to see that, of course, we can be able to describe the concept of an image, as we had said from our first case, especially in the concept of zero functions and the polynomials. So secondly, we're going to look at the cosine. And of course, the cosine as well is going to consist of a range of these specific real numbers defined as the cosine over x. So we can be able to, or we can express this one in terms of the cosine over x, whereby this value for x as well is going to consist of a set of real numbers given in this specific case as for all x values, whereby x is a set of real numbers given as such. So for the sine and the cosine of a function, we're going to have these specific conditions which are going to be applicable. And as I said, of course, we are going to consider that this specific value of x given in terms of radians given as such. Of course, I have mentioned that from the degree conversion to radians, we can express this particular conversion using of course, the two sets for angle measure using either radians or degrees are given as such. And of course, that is going to be the conversion factor that we're going to consider. Now, the two above functions are going to consist of a domain, or what we refer to as an image, given as an image that is going to consist of a set of numbers given as a 1 and negative 1 given as such. And we already discussed this specific, of course, condition in our first set of 0 and polynomials respectively. So the next set of functions we're going to look at is basically these reciprocals of these functions and their specific representation. And of course, we're going to start with the tangent of a function that we have mentioned, which can be represented as a set of R, whereby we had mentioned that R now can be given in terms of a half into 2n plus 1, of course, in terms of radians. And as we had said, of course, we can be able to give this value of n in terms of a set of real numbers given us. So I'm trying to So basically these are going to be integers, not real numbers. So kindly try to be taking note of these various conditions that we're going to give, and I'm going to give this one in terms of a summary so that we are able to follow as we said. So from our previous discussion, we had said that we can be able to define the concept of a term of a function, let's say x, in terms, said that x is going to be a set of all real numbers given as such. So the term of a function of x can be defined as the ratio between the sine over x over the cosine over x. So as we are going to define these two specific terms, we can be able to represent the term of a function using that specific ratio. So in this case, this is going to be the general representation of a function of a term, whereby we're going to have it represented given as such in terms of a pi, as I had said. So next we are going to look at the concept of a cosec. And as we said, of course, a cosec can be as well represented in this specific case using a set of numbers given as n pi, whereby, as we said, this particular set of numbers for n, of course, is going to be given as a set of integers. And of course, we can be able to express this particular function over the cosec as, of course, the inverse of a sine. So we have decided that the concept of a tan is equivalent to this one is tan of a function is equivalent to the sine over x over the cosine over x. And the various, of course, reciprocals of these specific terms can be given in terms of cosec, sec, and cot. And the first one is cosec, which is an inverse of a sine. So the cosec of a function x is equivalent to 1 over the sine over x given as such. And we're going to borrow from that specific representation, of course, from the general representation we have discussed in our previous videos on the concept of trigonometric ratios, and that is going to be complementing on this specific discussion. Then we're going to look at the second, the third, which basically represent the sec. Now the sec of a function is going to represent a set of course, numbers represented in that specific order. So in our first case, we had represented the concept of a term in terms of a half, this one that is given above, half 2n plus. And for the sec, of course, is going to be having this specific representation, whereby the n represents a set of integers given as z. And the sec can be defined in terms of the inverse of a cos. So we can give sec in terms of the sec x is equivalent to 1 over the cosine over that specific function, which is x given as such. And as we said, of course, x is going to consist of a set of real numbers as are given above. So lastly, we're going to look at the inverse of the last one, which is going to be given as a cot. And this cot is forming a set of real numbers that we can express in terms of n pi, just as we had done for this one, whereby n is a set of integers given as z. And this, of course, is going to form our last bit of it, whereby we can be able to define this cot in terms of the ratio between, or the inverse, whereby cot is the inverse of tan. Now we are given tan in terms of the sine over the cosine, so therefore we can be able to define the inverse of tan in terms of the cosine of a function, or cosine of x over sine of x, given in that specific format. So these are the various representations that we may come across in our discussion on, of course, the elementary real functions of our calculus. So in case we give a representation of the function of the cosine over x, then therefore they are going to obey these specific conditions. Now I'd say that this angle measure or our function can be expressed in terms of radians, or in some cases we're going to see that they're going to be exploiting the concept of degrees. Now I've mentioned that for the sine and the cosine of a function, of course, they're going to consist of images of those specific intervals, or images of those specific of a set of real numbers given as -1 and 1. And of course, for the function of the tan and the cot, they're also going to have the similar description, whereby their images are going to consist of -1 and 1 in that particular respect. So I'd say, of course, we can be able to either express these ones in terms of radians or degrees, and we're going to use various examples in trying to, of course, demonstrate this specific concept. So for now, I hope that we have understood how we can be able to represent the three basic functions of the cosine, sine, and the tangent using these particular representations. And of course, there are various inverses which I've given, of course, which consist of these three basic functions which I've mentioned. So kindly check our description boxes for various links of other similar videos, and also check our, of course, I'm going to put it in terms of a playlist. So kindly open those links and check the similar videos and give us a feedback in the comment section so that we can be able to assist one another in various discussions, perhaps in terms of a discussion or feedback that we're going to receive and act on it. So that is it for now, guys. By God bless you. Catch us in our next video.